back to Physics World. Today we are going to do Magnet Mania, which is a lab that we would typically do at school, but as you know, we're not. So we're going to do it in my kitchen, but I will do all the heavy lifting and then you write it up. So what I have here is a bar magnet with north-south poles. And I'm going to place it on paper on top of this, and now I'm going to shake the iron filings around it. See how you're getting nice curvature from the north to south. Notice how my poles pick up the most magnetic filings. That's because they are the strongest at the poles. But I get that nice curve, and then I have the field lines leaving. So we're going to do that with some other examples. So now I'm going to take a north and a south pole, put them right there. I'm going to put my paper on the top of it. And now I'm going to we're going to shake the iron filings. And you're going to draw what you see here. See how they're attracting each other? Because different poles attract. And I have it going north to south. Next, we're going to do two poles that are the same. So I'm going to flip this bar magnet over. I'm going to do two north poles, leaving them about 2 centimeters apart. Again, we're shaking the iron filings on it. Now look what happens this time. See how they're repelling each other, and I get these hyperbolic curves on the edges where the field lines don't cross each other, and I'm seeing the repulsion of the two. Now we're going to put the bar magnets. So the north and north pole, south and south pole going to line up. And you still get the repulsion of the curves here and here. And we see more repelling in the middle of it. Now we're going to do the same thing, but we're going to flip one of the poles around. So we'll go north-south, north-south. See the difference of this one. See how they are attracting on the poles. And we have them going north to south, and we get that nice curve. I have one last one I want you to see. This is a horseshoe magnet. A horseshoe magnet is a bar magnet that's just shaped in a U, has a north and south pole. And see how we're getting that nice attraction between the north and the south pole. Alrighty, draw these. I'll see you in a bit. Hi, we are now going to look at the floating disc part of the lab. Now see how I have these ceramic magnets. They're just regular ceramic magnets, and they are floating in air. So if I put this on, see how it floats, won't touch the other one. Notice what happens if I take this magnet and I flip it over. Now all of a sudden it attracts that one. So I flip it over and I put it back. Now go up and down, and it's very fun to play with. Now the other one I wanted you to look at is this bar magnet I have. Now a bar magnet has a north and south pole. I have a compass here. The red part of the compass is going out of the north, and it comes right around, and it goes into the south pole. So out of the north into the south. Now look what happens when I break this bar magnet. So using my amazing strength, I'm going to break this bar magnet, boom, in half. But look, it looks exactly the same. So coming out of the north and going into the south. What if I made it even smaller? So I broke it again. See how this part does exactly the same thing. All right, what would happen if I made it even tinier? That's your job to figure out. All right, I'll be right back. Hi, now we're going to make a temporary magnet. So I have my bar magnet and I have this regular common nail. So I'm going to try and use this common nail to pick up these paper clips, and nothing happens, which should not be a surprise to anyone. Now I'm going to use my bar magnet. I'm going to attach it to my nail and see how it attracts. Now I'm going to use it to pick up these paper clips and see if I can pick up both of them. Almost, there we go. Now if I let go of this, see how it's no longer a magnet. Now I'm going to try it with this copper one. See how the copper one doesn't pick up anything? Now I'm going to try it with this bar magnet and nothing happened. All right, so then my last one I wanted to show you is one of my favorites. This is a paper clip suspended by a thread. Notice how it's being attracted to this bar magnet. So it's floating in midair, just like magic. I have a pair of scissors. Now, we remember from the earlier video how there are magnetic field lines and how they curve like this. Well, I'm going to take my scissors and I'm actually going to cut those invisible field lines. See how my paper clip's moving back and forth? Because of those invisible field lines that I'm actually cutting. I'm going to try and cut right here and see what happens. Oh. So let's put it back, and I have some materials and we're going to try those. First one is copper. I think you have a good guess at what's going to happen there. Nothing. Then I have brass. I have zinc. And then I have iron. Well, guys, it's been a long time since I've seen you. I hope you are well. I hope you're taking care of yourselves. I miss you terribly. Bye.